Okay, so let's do that. Then the CDF x is again defined as from 0 to x, the PDF, which is sin theta d theta. Okay, and this is again we know that the integral of sinus is minus cosinus, so this is actually going to be minus cosinus theta from x to 0, and this is equal to minus, so let's write it as follows: cos x minus cos 0, and this is what is it equal to? This is equal to cos 0 is equal to 1, right? So this is actually equal to 1 minus cosinus x. Okay, so the CDF for this one is equal to 1 minus cosinus x. Okay. Now in the next step we will what are we going to do? We are going to find the inverse of this. Okay, so let's clean this part. Now the inverse is the inverse when you give it as an input should give you x on the output. So 1 minus cosinus p minus 1x is equal to x. Okay, and from here we can see that cosinus minus 1, inverse like arc cosinus, cosinus 1 minus 1, 1 minus x is equal to the inverse of the CDF. Okay, so again then in order to sample the theta value, what are we going to do is we are going to generate a random number and give it as input to this one. Okay, so cosinus minus 1, 1 minus chi, chi 2i. Okay, so now one substitution that we can do is note that chi is a random number between 0 and 1, right? So 1 minus that random number is again going to be a random number between 0 and 1. And it doesn't change the distribution. So instead of using 1 minus this, you can directly use, here you can say chi 2i, okay? I mean, we made that substitution because you could derive a number, a random number, and subtract it from 1, or you can directly use it. They are going to be again the random number with the same distribution. Okay, so this is our conclusion. Now, in order to sample a uniform direction on the hemisphere, what you do is you generate two random numbers, chi 1 and chi 2. And the phi parameter, the phi spherical parameter, is then found with 2 pi and chi 1. And the theta spherical parameter is found by cosinus minus 1, chi 2. Okay? So you find these directions. And once you find these directions, theta and phi and theta, you can compute the x, y, z to find the direction that we need. Okay?